So just to reiterate the flexibility of Scala syntax, let's just quickly take a look at values and variables again. So if we have this and this, these are the same things because, again, just to reiterate, in Scala we do not have to provide an explicit data type when we're creating a variable or a value. Inference will take care of that for us. However, if we choose to, we can, and there would be situations where it would not be possible, it wouldn't be possible for the runtime to figure that out for us. In any time or situation where it would be possible for the type inference system to determine the type that we're using, we do not have to provide it. So just to clarify that. The same again works for values as for variables. So val1, name1. This is the same thing as this. There's no difference in them whatsoever. So just to make sure that we're clear on that. Okay, so functions and methods. So since we're dealing with Scala, which is a functional and an object-oriented imperative language, we have to deal with both functions and methods. So if we talk about C or if we talk about Java, it makes the distinction between these two things very clear-cut, really straightforward. So in C we're dealing with functions because it doesn't support classes or methods. And in Java we're dealing with an object-oriented language that doesn't, or until Java 8 did not support functions other than those that were members of classes and by definition were methods. So when we look at a language like Scala, because it supports two different paradigms, it either makes the distinction between functions and methods really clear and really straightforward because the two of them are working side by side in the same programs and in the same runtime, or it just muddies the definition between the two of them because they're both working together in the same runtime. So it depends on how you want to look at it. Really, they're two different things. Obviously, we've all learned what they are. However, even Odersky in his book Programming in Scala tends to use the words interchangeably, as do a lot of programmers or even academics. So is it semantics? Is it a real true difference between the two of them, and we should not be using the terms interchangeably? That's up to you to decide. You encounter both of them in Scala though, so however you want to look at it. By the way, Odersky's book Programming in Scala, the first edition is available online in its entirety for free. Link is in our notes. It's really the definitive reference for Scala. He came up with the language along with a few other gentlemen, and this is their work on that. There's a second edition now in print, I think since 2012. The first edition will give you what you need though. Also, if you're familiar with Coursera, Odersky himself teaches functional programming principles in Scala, a course that's just finished its 5th iteration on Coursera, just while I think of it, if anyone's interested in those. So back to the interpreter, let's take a look at functions and methods. So just for sake of clarity, and because I'm not dealing with objects yet, I'm just going to say functions from this point on until we start looking at objects. So functions are defined with the def keyword. So what we're going to do here is we'll take a look at a couple of functions. They'll perform the same task. We'll do it with different syntax, just again to demonstrate the flexibility in Scala's syntax. So def increase age 1. We're going to make a second one, so we'll differentiate them this way. The name of the function is increase age 1. It accepts one parameter. It's called age, and it's of type int. The colon after the parameters, the input parameters, explains that it returns a value. That value will be of type int, and this is the body of the function here. So return age plus 1. And actually, just to make it as Java friendly as possible, we'll put a semicolon at the end of the statement. So there we've got a function called increase age 1 defined. Now, increase age 2 also accepts one input parameter. Now we're going to skip the fact, we're going to skip explicitly stating that it returns a value, and we're just going to define the body here, and we're actually not going to even use the return keyword, as well as skipping the terminating semicolon. So there we go. We have two functions, increase age 1, increase age 2. They do the same thing. They accept an age as an integer, and they increase it by 1. So just to show they're doing the same thing here, let's assign it to a variable actually. There we go. And the same thing with 2. Same result. So you can see the difference in the syntax here. First time we declared explicitly what the return type was, and that there even was a return type. Excuse me. We also used the return keyword and the terminating semicolon, just so everyone is familiar with Java, feels at home. The second one, we did something a little more Scala-ish, I guess you could say. We've accomplished the same thing with a couple fewer words. Not that big a deal in the grand scheme of things, but you can imagine if you're writing hundreds and hundreds of lines, this could really genuinely save you an awful lot of typing in the long run. So, yeah, return keyword is always optional in a function, in a Scala function, with the final expression result always being returned from the function. So in our case, each of those functions only has one expression in it. So the result of that expression, age plus 1, is what gets returned. We can use return, the keyword, of course. It's absolutely completely ignored though by Scala runtime. The terminating semicolon is always optional. Curly braces are optional if a function contains, or any code block contains only one statement, which is like Java, C, C++. If you've got an if statement, it only has one statement included in it. You don't require the curly braces. Also optional in Scala are the empty. We haven't looked at this yet, but the empty parentheses when calling functions that don't have any input arguments. Also the separating dot when calling a single unchained member function or method of an object. we'll take a look at those when we look at objects next.